So hey guys, welcome back to another lecture. So today we're going to cover, we have covered in our previous lecture what is variance. So today we're going to cover what is covariance. So like what do you mean by this covariance? The covariance tells the direct relationship between the two random variables. Here it is telling the direct relationship between the x and y. It is telling this relationship. This is covariance. This is the one of the pretty straightforward definition for the covariance. Like it tells the direct relationship between the two variables, which is x and y here, right? So like how they're gonna tell that the relationship? There are two kind of these relationship, which is directly proportional and inversely proportional. So what do you mean by this directly proportional? Means like if we have the same directions, either it may be up or down, then we simply called it as a directly proportional. Means like if one goes up, another one also goes up. If one goes down, another one also goes down here, right? So what do you mean by this inversely proportional? Means like if one goes up and another one inversely, means like it opposite. One goes up and another one goes down, or one goes down and another one goes up, right? Right, it tells the direct relationship between the two variables, right? So like if the both the two variables tend to increase together, if the two variables tend to increase together, then we say that it is a positive correlation, right? If the both variables which one increases, means like if both increase, one increases and another decreases, then we simply say these are negative relationship, right? Negative covariance. So we have a small formula out there for the covariance. So if you look at the formula here, the covariance between the two random variables, which is x and y for random variables, okay? So how we gonna find that covariance? Means like we have a summation rule here, and then we simply subtract with the mean here. We simply subtract with the mean from x and from the y here, and then we simply divide by the n. This is for the population, right? And we have, if we have n minus 1, and that this is a sample data, this is for sample, and this, if we have a this n, and then this is for the population in a sample, then we simply subtract with the mean here, and then we simply gonna divide with the n minus 1 here, right? So the where x and y are the values of x and y variables, x bar and y bar are the mean of those variables, and then n is number of data points. I hope you understand this. So the covariance is nothing but it tells the relationship between the two random variables. That is a covariance, right? This is a covariance, and this is a correlation. So like it's another measure to examine the relationship between the two variables. So it is also another measure to examine the relationship between the two variables. While the covariance between two variables measures the direct relationship, right? So it measures the strength of that relationship or correlation. Means like it tells, means like the covariance, covariance tells the direct relationship between these two variables, and the correlation tells about the how much strength of that relationship, okay? So like it ranges from the minus 1 to 1. It ranges from the minus 1 to 1, and the correlation is mainly used in the linear regression. So like we gonna see this, what is linear regression, and first of all what is regression, all we gonna see in our machine learning lectures. You need not to worry, everything will be covered, okay? So if the correlation coefficient is minus 1, describes a perfect negative or inverse correlation in which one rises and another one decreases, right? If the correlation coefficient is 1, describes a perfect positive correlation in which the if if one increases, another one also increases. If one decreases, another one also decreases here. If the correlation coefficient is 0, then there is no relationship at all, okay? So the most common is the Pearson's coefficient, which measures the strength and the direction of the relationship between the two variables. So it's really difficult to understand like what is this positive relationship and a negative relationship, right? So I have given a detailed graph over there, a geometric intuition about how this. So if the data points are in positive direction, then we simply call it as a positive correlation. If the data points are in a negative direction, then we simply call it as a negative correlation. If there is no kind of relationship, if there is no, means like they are spread over these spread, if they are spread out, then we simply call that they have no relationship, right? So I hope you understand this. So like correlation coefficient equation, we have said like this: if the correlation coefficient is 0, then so what do you mean by that? Correlation coefficient means like, so what do you mean by this correlation coefficient equation means like, we have a probability of x and y, and we simply, then the covariance of x and y is divided by the standard deviation of x and the standard deviation of y. We have seen this standard deviation, right? So we just simply dividing these covariance of x and y with the standard deviation of those variables. So like the pxy is the Pearson product moment of the correlation of coefficient here, and these covariance of x and y here, and the sigma x, which is the standard deviation, which is also the square root of variance x, and the sigma y, which is the standard deviation of that y, so it is written as also the variance of y, right? So like how we gonna find these correlation? If the relation r is equal to the n into, n means the number of observations, into summation rule, means the summation into x comma y minus the summation x and the summation y into summation y, and it is divided by the, and number of observations into summation x square minus summation x square into n into summation y square minus the summation y square. It's a bit difficult to understand as of now, but means like we don't remember the formula. Okay, so we do in a computer, so it will be easy at there. So as of now, just have an idea like what is this correlation coefficient equation we're gonna do in the computer, so you don't have to be worry. Okay, so like this r is a correlation. Okay, so it tells how the data was spread out in this direction, and also tells about the relationship between those variables. Like we have seen this, right? So it tells how spread the data in that direction, and also tells the relationship, between those two variables, right? So I hope you understand these. And after, we have a joint probability distribution. So what do you mean by this joint probability distribution? Means like, it is a corresponding probability distribution and all possible pairs of outputs. It is a corresponding probability distribution on all possible pairs of outputs. So what do you mean by that? So like, I will explain a practical example so that it will be easy for you. Okay, so the probability distribution can represent probability of multiple random variables simultaneously. Means like, it can represent the random variables simultaneously. Means like, what do you mean by this simultaneously? Means like both at a time, right? So it can represent multiple probabilities both at a time. So here we have given a diagram over here, so I will explain it here. So the probability of both, which is x is equal to x, and the capital Y, and the capital Y is equal to, and y, and the probability is equal to the capital X is equal to x, and the y, capital Y is equal to the y, right? So for example, so like, we have a probability of k intersection 52. So if we have a deck of cards over there, so that deck of cards is 52, so I just want to have a k in that. And then how we gonna find these? Like, so if we have these two kind of these sets, and we have a two case here, two case, right? Two kings, in these two sets, right? So I just want this intersection, which is k, 2 by 52, which is 1 by 26. I hope you have a basic intuition about what is this joint probability. By the word, you can understand like joint means like it's combining. This is a intersection here. It same will happen at the same time. This is a one probability, and this is another probability event, and they both occur at same time here. Means like, we have a formula over there, which is a intersection b is equal to a p of a into p of b. We have seen it before, right? I hope you remembered that formula. I hope you remembered that, right? So this is a joint probability distribution. So after that, we have a marginal probability. So what do you mean by this marginal probability? Means like, it's a probability of a single event occurring without depending upon the other events. It is a independent, it is, which means like, it is a independent of other events. If one occur, then it is independent to the another. Means like, if you flip a coin, if it is head, then it might be the next event, it might be the head or tail, which is independent, right? So we have a formula over there, which is p of x is equal to a, and the sum, which is x is equal to a, and the y is equal to y1 here for all y. So this is referred as a sum rule. So like what do you mean by this sum rule? Means like for all x exi, which is p x is equal to x, we simply apply this summation rule here. We have seen this, right? We have seen this here. We have seen this, right? The probability of capital X is equal to, and the capital Y is equal to. I hope you understand this. So as of now, like if you understand, it's totally all right. Otherwise, just ignore it. We're going to cover in that Python, in the programming and on that ML part. So if I give an example, you might understand. Like, so like the total number of people is 30. Means like, so these 30 people went to the shopping mall here. So these 30 people went to the shopping mall, and the people who are vegetarian and the non-vegetarian. So the men who means like there are 16 men over there, and the 10 men bought the vegetarian fruits, 10 men bought the vegetarian, and the 6 men bought the non-vegetarian, and the 14 women bought four women bought the vegetarian, and the 10 women bought the non-vegetarian. Means like if we have at the total 14 non-vegetarian, and the 14 vegetarian, and the 16 is non-vegetarian. So how we going to find that marginal probability? Means like, so the marginal probability of food that people prefer is like, so we have a veg over there, right? So how we going to find that? We have a total, and we have a total of 30 members, right? So we just simply divide by the 30, and we will going to get the 0.46. And if it is non-veg, then we simply have a total of 16, and then we simply divided by 30, and we're going to get a 54. So these are the margins here. These are the margins. I hope you have a basic intuition like how we're going to use this marginal probability in our daily life. Okay, so after that we have a conditional probability. This is a marginal probability, and this is a conditional probability, which is an event which is depend upon the previous. This is independent of other events, but this is depend upon the previous event, and then they are independent, so they are dependent to each other. So the likelihood of an event occurring based on the occurrence of the previous event. So like, so it depends upon the previous event. So if I if I shake this bowl and I pick a red one out, and didn't replace that, red won't be there, right? So like then the number of variables are 3 here, and the red will come out, right? So the red won't be the output of that next event. It might be the yellow or gray or green, right? So like it is dependent, means like the outcome is dependent because we are taking out that. It is not replaced over here, over there. I hope you understand this. So like the two events are independent if one does not affect the another event. However, if one event occurring not affecting, means like they are independent to each other. Means like if this taken, if it does not affect these three, but the probability of these means like we have a probability of 1 by 4. If this is taken out, and then it will become 1 by 3, right? The probability of that other events are depend upon this red one. I hope you understand this. So if the events are independent, then it does not relate to the condition of probability. If this tossing a coin, which it does not relate to the condition of probability. So like the probability of A given B, which is the probability of A given B, is if we apply this conditional probability on that, the probability of B given A, which means like we are taking the probability of B in which the probability A is already occurred under conditional probability. We are taking B in which the probability of A is already occurred under the conditional probability. How we gonna find that conditional probability? So the probability of A and B and divided by the probability of A, or probability of A in intersection B divided by the probability of A. Means like if P of A, which is probability of A, is not equal to 0. If it is equal to 0, then it is undefined, right? I hope you understand this. So the special cases in the conditional probability. So there are some special cases in that conditional probability. So what are those special cases? So we're going to look at this. So when A and B are disjoint, which are independent, right? So what do I mean by this? Disjoint means independent. They are disjointing. If this joint, then we can say are independent, right? Joint probability, we have seen this, right? So the A intersection is not equal to null. It is independent. So like the probability of A given B, they are independent, right? So how are we gonna find this? How are we gonna find this? The A intersection B will become the pi, will become the null. So the A intersection B is will become the null. So the probability of null divided by the probability of that B, then it gonna result as 0. Since the A and B are the probability disjoint, so they cannot occur at the same time. So like if the B is subset of A, whenever B happens, A also happens here. If the B is subset of A, means like if, so this is a subset of A, then whenever B happens, A also happens, right? So if the probability of A given B, which is the probability of A intersection B by the probability of B. So these are the subset, right? So B is a subset of A, then it will become probability of B and divided by the probability of B, which is equal to, if we cancel it out, then the answer is equal to 1. I hope you understand this. I hope you understand this. So the conditional probability is used as a Navier algorithm, which is important in this machine learning. So we go into these in our machine learning lectures. Don't worry, all this. So as of now, just ignore this, okay? So I hope you understand these lectures. I hope you understand these topics. I just want to recapitulate what I have said before. We have seen the covariance. So it tells the direct relationship between the two random variables, right? So this correlation means like it tells the how much the strength of those relationship, right? So we have seen this positive correlation, negative correlation, and no relation at all. And we also seen the correlation coefficient equation, like how we gonna find this and how we gonna say like that this means the strength of that correlation. And we have seen the joint probability distribution. This is a joint probability distribution, and we have a marginal probability which is independent to each other. And we have seen also the conditional probability which is dependent to the each other, dependent upon the each other. So after that we're going to discuss the distributions. We have a uniform distribution and we have a normal distribution. We have empirical rule out there, and we have a geometric distribution, Bernoulli distribution, and a lot more. So I hope you love this lecture. Until then, bye bye, see you in the next lecture. If you like these lectures, please subscribe and share with your friends.